Bismillahirrahmanirrahim. The goal is to turn data into information and information into insight. My topic of presentation is ways of presenting data. In this presentation, I'm going to introduce you to different types of data presentation. We are going to discuss tables, bar charts, histograms, box plot, and stem and leaf plots. Learning outcome. At the end of the presentations, participants will be able to describe different ways of presenting data. Now coming to data. Data is any piece of information that can be counted, measured, judged, assessed, or observed. Now types of data. Data is broadly classified into quantitative data and qualitative data. Quantitative data is for the numerical data, which is further divided into discrete data and continuous data. In discrete quantitative data, the items can take up whole numbers, for example, number of admissions in the hospital, and there is no in between value. Whereas in continuous data, the items can take infinite values. For example, weight or height of a person weight can also be 10.6687 kg, so there can be infinite values in between. Now coming to the qualitative data. Qualitative data is further divided into nominal and ordinal data. In nominal data, the categories are made in a way that there is no order. For example, male, female, rural, urban. But in ordinal data, there is a order. For example, we can say that BMI can be classified into ordinal data. For example, the categories can be underweight, normal weight, overweight, and obese. Now coming to tables. They are simple form of data presentation. Every table must have a title. For in this table, the title is age distribution of patients in study, and the table must also have a table number. And the column captions are called as box head, whereas the row captions are called the stub of the table, and the rest of the table is called the body of the table. Now, use of tables. Tables can be used for both qualitative and quantitative data. There is an example. If we have qualitative data, for example, class score in test can be categorized into good, medium, and poor. We can also show frequencies. So and when we also have quantitative data, where we have numerical data, we can also draw a table. Now, if more than one variable is being classified or is categorized into tables, so it is known as bivariate table or two-way table. Coming to histogram. Tables can be used for both qualitative and quantitative data, but histograms can be used for quantitative data only. In histogram, it's a graph where there are bars and there are no gaps between these bars. On x-axis, the normal ranges or the class intervals of quantitative data are being used, and on y-axis we have the frequencies of that distribution. Now, in contrast, the bar to the bar charts which have gaps in between the categories. Now, this is a picture of population pyramid. If we look at one half of it, we can see that there are horizontally placed histograms as there are bars, and there are no spaces between them. So population pyramid is a double-sided histogram in which class intervals are taken in the vertical direction and the frequencies are written in the horizontal direction. Coming to the frequency polygon. If we join the midpoints of the histogram, a frequency polygon is made. So as it is made on histogram, so it is also used for the quantitative data, and it gives us idea about the shape and distribution of the data set. Now, another form is ogive. It is also used for quantitative data. In ogive, we use the cumulative frequency. Now, what is cumulative frequency? It is the frequency in which the class and above the class interval is added. So looking here, in class 0 to 10 we have 1. So cumulative frequency is 1, because there is no class above it. And in 10 to 20 we have frequency 4, so we will add 1 and we will get 5. Now why is this used? It allows us to look at the frequencies that are below a particular numbers. For example, we want to see that below 50 how much frequency or items are there. So there are 22 items in this case. Now, a brief difference between cumulative frequency and relative frequency. In cumulative frequency, we added the class interval above to get cumulative frequency. It gives us idea about the number of items below the particular number. In relative frequency, for example, we want to know that how much students fall in weight between 40 to 49 kg. So there was the frequency was 3. So in relative frequency, we take the frequency and divide it by the total number of outcomes, that is 22. So it is the number of times a value occurs divided by the total outcomes in the study. Now, coming to the bar charts, we have studied that histogram, frequency polygon, and ogive were used for the quantitative data. Bar charts are used for the qualitative data, and it tells us about the differences in categories of nominal and ordinal data. And about the bar chart, the categories are displayed as rectangles of equal width. The width of all the bars are equal, and height is proportional to the frequency of the category. So this is a bar chart about the occupation of respondents in a study. So we can see that 12 respondents in the study were teachers. Coming to the stacked bar chart, it is a bar chart that is used to show comparison between categories of data. And we use it when we want to focus on the total and one part of total. For example, we want to know the gender distribution of respondents in different cities. In Lahore, the total participants were 6, and we can also know that the 4 out of the participants were males. So it allows us to make comparison about total and part of total. Now, multiple bar chart. It shows relationship between different values of data. They are useful for comparing same items in different groups. For example, we have done a study on comparison of snacks in school-going children of different cities. The 3 cities are Lahore, Karachi, and Islamabad. We want to know that how many of them consume ice cream during their break time. So we can make comparison: 5 in Lahore, 6 in Karachi, and 2 in Islamabad. And we can also use multiple bar charts over for multiple times to show comparison over time. For example, we can say that the comparison between the cases of Lahore, Karachi over time. Now coming to pie chart. Pie chart is also used for the qualitative data. It shows differences in frequencies or percentages between the categories. In qualitative data is further divided into nominal and ordinal data. It can be used for both the nominal data and ordinal data. data. This is a chart of gender distribution in study, which is a nominal data, and class performance of students. This is an ordered category, so this can also be shown in the pie chart. Now coming to the line graph. A line graph shows information about changes over time. On x-axis, we take time, which can be months, years, or days. On vertical axis, we can take the number of cases, population, or any information which is being plotted, and we plot the points. Now these are called the points. The number of the population is being plotted. In January, it is around below 12,000, and it's 12,000 in Feb. And after plotting the points, we join them with a line. So this is known as line, and these are the points. And we also give title to the line graph. Now coming to box and whisker plots. Box and whisker plots are used for looking at distribution of data among the set. It groups the numerical data into quartiles. So a box and whisker plot, it uses 5 number summary of set of data: minimum value, the lower quartile Q1, median, which is Q2, upper quartile Q3, and then the maximum number. And outliers are plotted as dots. So it gives us idea about the distribution of data with interquartile range. Box and whisker plots are useful in studying the distribution of data between different sets. For example, this is a study of breast cancer type, and they are seeing the SOX3, which is the gene expression. So they have plotted gene expression in different types of breast cancer. So we can compare the data sets, the minimum value, maximum, median of the data, and first quartile and the fourth quartile. Now coming to stem and leaf plot. It is used for the quantitative data. It expresses the quantitative data in graphical format similar to histogram to assist visualizing the shape of distribution. So in histogram, we can visualize the shape of distribution. Another way is stem and leaf plot. For example, this is a data set showing 15, 16, 21, 23, and onwards. Now in distribute in stem, we take the first number, for example 1, and then we put the categories 5, 6. So in this this is 15, this is 16, so we distribute it into stem and leaf pattern. It helps us to identify the distribution of the shape of the distribution. So we can see it here. Now coming to the scatter plots. Scatter plots are again used for the quantitative data. It shows relation. It is done to plotted to show relationship between two numerical variables. For example, we want to show look at the relationship between weight and height. Both of them are numerical data, and we have plotted different points to look the relationship between them. These are the different shapes we can get while plotting a scatter plot. This is a strong positive correlation. If one variable increases, the other variable also increases. This is moderately positive correlation, and there can be no correlation between two variables. Then if one variable increases, the other decreases, so there is a strong negative correlation. Then we can also have curvy linear relationship. For example, if we have anything which is which has high value at the start, and then we have low value, and then again high value at the end, we can have curvy linear relationship. Now, another way to present data is by pictograms. Pictograms are charts that uses pictures to represent data. For example, we have plotted the number of children who use it, who use pear, watermelon, and we have make pictures. This is another pictogram which is showing health in numbers, doctor available per 1,000 population. In Cuba, it's 5.9 doctors, Spain 3.2 doctors, and Canada 2.1 doctors. They are useful in giving information to general public, where it is easy to understand the data from the pictures, and it can also be used for illiterate people and for children who are young. So it gives an idea about the data easily. Now, another method is the area map or choropleth map. Now, data, these are made by software. Most common use software is Geographical Information System. Now, data is collected from predefined areas, and color pattern is used to represent the proportion of statistical variable in that area. For example, this is an area map of Pakistan. In this, we have divided the predefined areas according to the provinces, and then we get data about the confirmed cases of COVID, and we have classified it into according to the burden of disease or incidence of disease, according to categories or colors. This helps us to identify the magnitude of problem in a particular area. This is another map in which COPD prevalence is being measured. So it helps us to identify where the problem is greatest in the map. Now it's time for the MCQs. A researcher wants to graphically represent gender distribution in a study. Which of the following is the most appropriate method? Histogram, frequency polygon, ogive, pie chart, scatter plot.
Pie chart.
Yes, the correct answer is pie chart, because the other options in the were for the quantitative data. Histogram, frequency polygon, ogive, and scatter plot are used for quantitative data, not for the nominal data. A public health expert wants to graphically represent the change in number of cases of tuberculosis in past 10 years in a community of Lahore. Which of the following is the most appropriate way?
B. Line diagram.
Yes, the correct answer is line diagram, because in line diagram we take time interval in the x-axis, and on y-axis we plot the number of we will plot the number of cases of tuberculosis per year. Question number 3, a researcher wants to compare distribution of data of 3 studies in which height of children were taken. The best method to compare distributions of data set will be?
Box and whisker plot.
Yes, the correct answer is box and whisker plot, because in box and whisker plot, we can compare different data sets distribution by using quartiles. The other options were not suitable in this case. As a public health expert, you want to show that 1 in 7 women suffer from breast cancer at some point in time to a rural community where literacy level is low. The best method to increase awareness of community by posters and banners will be?
Pictogram.
Yes, the correct answer is pictogram, because for illiterate community or for children, you can use pictogram to show data graphically. Which of the following is best interpretation of the scatter plot shown here?
Strong negative correlation. B.
Yes, it's a strong negative correlation, as the value of x is increasing, the value of y decreases. Leukemia has high incidence in children under 7 years and then after 60 years of age. Scatter plot plotted between incidence of cancer and age in years. Scatter diagram will show
Curvilinear relation.
Yes, it will show a curvy linear relationship. As we can see in the numerical, the incidence is high under in children, and then it decreases, and then after 60 years, the incidence of leukemia rises again. So we will have a curvy linear relationship. A student graphically represented distribution of age in study by bars with no distance between the bars. After that, he joined the midpoints of all bars to make a curve. Which of the following curve must have been drawn?
Frequency polygon A.
Yes, the correct answer is frequency polygon, because frequency polygon is obtained by joining the midpoints of bars in the histogram. A data set of number of admission in hospital per day is shown. Now there will be there were 9 admissions in a day. The manager wants to add 9 in the existing graph. How will this be done?
Add 7, 8, 9, and 6 in the stem column and write 9.
Yes, the correct answer is B, because in stem and leaf diagram, the stem is taken here. So in 9, the stem is 0, and we will add the 9 in the leaf after 8. A researcher wants to tabulate age distribution in a study. Which of the following is the most appropriate method?
One-way table.
Yes, the correct answer is one-way table, as there is a single variable the researcher wants to tabulate. Epidemic curve is a type of.
Histogram.
Yes, the epidemic curve is a type of histogram, and histogram doesn't have spaces between the bars, but there can be spaces if the frequency of the case is 0 in a particular class interval. So if the frequency is 0 in that class interval, in that case, the histogram can have spaces between the bars. These are the references of my presentation, and thank you.